Okay, picking up with this problem, domain and range. So there was my function. It says use the graph. And so let's recall. Graphically, the domain was the leftmost x-coordinate to the rightmost x-coordinate. Well, when I look at my graph here, it's going left forever to right forever. And so my domain will be negative infinity to infinity. Now let's think in general about parabolas. All parabolas have that same basic shape. Either they open up or they open down, but they're all that U shape or the inverted U shape. They all go left forever, right forever. All parabolas do that. So the domain of a quadratic function of a parabola is always negative infinity to infinity. Always. And so instead of reasoning this out every time, we're just going to memorize that the domain of every quadratic function that's out there is negative infinity to infinity, because they all go left forever and right forever. Then range was lowest y-coordinate to the highest y-coordinate. CORD standing for coordinate because I ran out of room. Well, when I look at my graph here, both sides are going down forever. And then my highest y-coordinate happened to be y equal negative 6. So my range is going to be negative infinity to negative 6, square bracket on that negative 6, because we have an actual honest-to-goodness y-coordinate of negative 6, so we want to include it. And then remember, infinity, negative infinity always gets parentheses. And there's my range. Now the range on all parabolas will differ from parabola to parabola to parabola. But there is going to be some commonality. The range is either going to be negative infinity to the y-coordinate of the vertex, or for when a parabola goes up, it's going to be the y-coordinate of the vertex to infinity. So that y-coordinate of the vertex is always going to make an appearance in the range. The range is always going to be negative infinity to whatever that y-coordinate is of the vertex if my parabola is going down. And if we flip the parabola up, the y-coordinate is going to be, it'll be the y-coordinate of the vertex to infinity. Now these things can check, and you've got a few moments at the end of a test. Check these things. Let's look at this on a calculator. So there's my calculator. I've actually got batteries in it this time for those of you that have watched some previous videos where I didn't have my batteries in there. Let's type in that original function, which was negative 2 times x plus 3 quantity squared minus 6. Now, what frequently works in many algebra things is that you can just, and these are T83s, 84s. If you have a Casio, I don't know how you help you on a Casio or Sharp calculator, but 83s, 84s, what almost seems to always work is that standard window. I press zoom and then 6, the standard window. And that's all I see. Now that makes me feel fairly good about my vertex. Now we can actually check that vertex. If you press trace, and notice when you press trace, up comes where the cursor is. It can't see the cursor. The default setting, I'm going to zoom in a little bit here so you can see it a little bit better. When you hit trace, the default setting is it goes to the y-intercept. And you can see down there it says the y-intercept is negative 24. Notice the x-coordinate is 0, y-coordinate negative 24, so that is the y-intercept. And that's what we calculated before, that the y-intercept was negative 24. But we don't see it because we did the standard window of -10 to 10, so that wasn't an appropriate window here. But what I started with before I went off the track and said, there's my y-intercept, is that we can check that vertex. I press trace. I think the vertex has an x-coordinate of -3, so I can just type in -3, and notice down here it then gives me -3, and then hit enter. And it goes to that point, and we can see that blinking cursor, and indeed that's at the vertex, and then it tells me that coordinates down below, -3, -6, so that actually checks. Now let's get a better window here. I don't need all this blank space up here, and my y-intercept was clear down at -24. So let's hit window, and we'll still stay with the -10 to 10 on the x's. But on the y's, my y-intercept was -24. It's only going down to -10. That's why I'm not seeing the y-intercept. So let's go a little bit further. I'm just going to go to -30 just because that's the number I picked. And we didn't have anything going on above the x-axis, so I don't really need to go all the way up to 10. And I'm just going to go to 3. I pick something positive so I can still see the axes. If you want to see the axes, your maxes need to be positive, your mins need to be negative. And then I certainly don't need to count that off by ones, so I'm going to count that by 3. So what my window is going to do here, it's going to label my x-axis from -10 to 10, counting by ones. It's going to label my y-axis from -30 to 3, counting by threes, and then just press graph. And you should see a picture that doesn't look too far off from the picture you drew. And it doesn't. And then again, we can check these things. Like I said, if we do a trace, it automatically goes to the y-intercept, and we can now see that blinking cursor. And it does say that the y-intercept is at 0, -24, and we already did check the vertex. So all of these things check. If you've got a few moments, check them. Check, check, check. That's a good thing to do. And there's that problem. So on to the next one. Zoom back out a little bit. And so the next problem, pretty similar. Use the same instructions. Use the vertex and x-intercepts to sketch the graph of the quadratic equation. Give the equation of the parabola's axis symmetry. Use the graph to determine the domain and range. Okay, same things. So the vertex again. In this case, is going to be 4, -24. And again, you're doing the opposite of the number inside and the number on the end. As long as it's written in standard form. If it's not written in standard form, go ahead and rewrite it. The y-intercept, always plug in x equals 0. Always, regardless of whether it's a parabola, quadratic, cubic, plug in x equals 0. So y is going to be f of 0. It's going to be 0 minus 4 quantity squared minus 24, which is going to be 16 minus 24, which is -8. And again, if you were being a perfect person, it's the point 0, -8. X-intercepts, set equal to 0 and solve. Always, no matter what sort of function you have, set equal to 0 and solve. So x minus 4 quantity squared minus 24 equals 0. Again, the easiest way to do this is going to be the square root method, because I have square and numbers. But you could multiply it all out and do something else. That's not wrong. It's just not the easiest way. I'm going to take the square root of both sides. We'll go up there and do that. Remembering that all important, plus or minus. So plus or minus the square root of 24. So that gives me x minus 2 equals plus or minus. Simplify this. 24 is 8 times 3. And so moving the 2 to the other side, I'm going to get 2 plus or minus. And why I picked 8 times 3, not a clue. I mean, 8 times 3 is certainly 24. But remember, when we are doing simplifying square roots, I need to know one of the values, the square root of one of those values. I don't know what the square root of 8 is. I don't know what the square root of 3 is. So that was not the best choice to make there. Just guess not paying attention. Let's go with 6 times 4 instead. Indeed, 6 times 4 is 24, but the square root of 4 is 2, leaving behind the square root of 6. And there are my x-intercepts. And that's what you tell me. Now, the computer does not have a plus or minus, so for the computer, you're going to list them separately. And don't change them to decimals. That's not what I want, and it's generally not what the computer wants. Now, every once in a while, the computer will want a decimal, and if it says make them a decimal, make them a decimal. But don't make things a decimal for me unless I happen to say, and I will very rarely say, change things to decimals. The axis of symmetry. Always the x equals the x coordinate of the vertex. So in this case, x equal 4. My vertex was 4, so my axis of symmetry is 4. To graph, we have f of x equals x minus 4 quantity squared minus 24, or very specifically 1 times x minus 4 quantity squared minus 24. A is 1, that's greater than 0, so it opens up. So graphing this. And again, I'm not looking for huge works of art. The vertex is 4, negative 24. So let's just call that 4, negative 24. I'm going to go negative 8, negative 16, negative 24. So there's my vertex, 4, negative 24. My y-intercept was negative 8, so there's my y-intercept. Now, if these numbers had come out to be nice numbers, I would plot those too. But they didn't come out to be nice numbers, so I'm not going to worry to plot them because I'm not looking for major works of art here. And then we can connect the dots. And there is a good enough graph. It's not a particularly pretty graph, but that's good enough. And then the domain and range. Well, we talked on the last one that for every quadratic function, every parabola, the domain is always going to be negative infinity to infinity. It goes left forever, right forever, so negative infinity to infinity. Range. Again, that's your low y to high y. Using abbreviated language, lowest y-coordinate to highest y-coordinate. Well, in this case, my lowest y-coordinate is negative 24, and then it's going up forever, so infinity. And like we said on the last problem, your range is always going to be either your y-coordinate of your vertex to infinity when we open up, or like the previous problem, negative infinity to my y-coordinate if we open down. Your range is always going to be one of those things. Negative infinity to the y-coordinate if it's going down, y-coordinate of the vertex to infinity if it's going up. And then, of course, you could check this one the exact same way we checked the other one. I will leave that up to the reader or viewer to check it, and we'll end this video.